Engineering. Dr. Tiwari is currently serving as Dean Academics and Head of the Department of Mechanical Engineering at UIT RGPV Bhopal. Within exceptional 30 plus years of teaching experience, updated their research, and 7 PhD scholars are currently pursuing their research work. Sir has an outstanding academic record with 80 plus research papers published, including 15 SCI Index research publications, 25 UGC papers, and over 500 citations. In addition, Dr. Tiwari has also authored a book which has been recognized and awarded by AICT. So, huge round of applause for Dr. A.C. Tiwari ji. His major research area include alternate automotive fuel, electrical, alternate refrigerant solutions, industry 4.0, solar energy, sustainable energy. It's true. We are honor Dr. Tiwari sir is a true inspiration for researchers and students, known for his academic excellence, research leadership, and contribution to innovation in engineering and sustainable technologies. Now, I would like to request Principal Ma'am, please to welcome Dr. A.C. Tiwari sir. Please come on the stage, sir. जोरदार तालियां बजा दीजिए। बहुत बहुत धन्यवाद सर, आपका स्वागत है। Thank you, ma'am. We are truly honored to have Dr. A.C. Tiwari sir with us today. Sir, we welcome you and request you to enlighten us with your valuable thoughts.
Thank you. Okay. Thank you for this introduction of mine, and I'm totally obliged for such a wonderful introduction of mine. Now, without wasting time, I would like to come on the topic of today, which is innovation and challenges on good afternoon, everybody, and good afternoon, Principal Madam and all the staff members. And we start without much waiting. We start the deliberation of today. Innovation and challenges on innovation and challenges on adopting biofuels option for sustainable development. So this is the topic for today. Now this yes. To begin with, I start with some of the motivational and inspirational quotes. One from the down south, Thirukurul. He says that if those who think to achieve have a firm and the focused mind, they will realize what they thought of, and even as they have thought of. Now, another inspirational and motivational sentence is connected to another silver lining in the dark cloud. It says that the indeed one's faith in one's plan and methods are fully tested when the horizon before one is the blackest. This is by our own Mahatma Gandhi, none other than. So with these beautiful motivational, inspirational quotes, I start the presentation. Now we have got some introduction about the biomass content, and this slide is only moreover data. This slide is moreover data. So data is connected to biomass of the world. The total world biomass content is 1,880 billion of tons. So this much of the biomass is contained in the world, and total mass in the tropical forest is about 1030 billion tons. So this is the data about all this thing here. If you convert this amount of the biomass into energy form, the energy stored in terrestrial biomass is 25,000 exajoule. Exajoule is a bigger unit of energy, and exa stands for 10 to the power 18. 10 to the power 18 stands for exa. So this is a bigger unit. The net annual production of terrestrial biomass is about 400 billion tons. So these are the data which are connected to the biomass potential of the earth. Now the biomass energy consumption in the world is about 55 exajoule, whereas potential is about 25,000 exajoule, and the consumption is only 55 in exajoule only. So there's a big gap, and a lot of exploration and a lot of gap is there in the availability and the consumption. So it can be consumed for various purposes. Let us talk about that. Now, next is the utilization of the biomass as the energy source in the world. Let us see that the most highlighting data in this slide is, you can see that developing countries are consuming the biomass of the order of 76%. And only developed countries like America, Canada, and Europe, they are only consuming 23%. So clean fuel, sustainable fuel, the developed countries are using less, and we are developing countries, and we are using, Nepal is using 95%, small country. So this is the utilization of the biomass. As the L just that, now the what is the biofuel generation? Now biofuels are categorized into 4 categories. The first category is the first generation biofuel, the food-based source. What is the first generation biofuel? The food-based sources, the food crops with the high sugar content, the food crops with high sugar content, starch or oil content. What is the food which is a large oil content, like sesame seeds, groundnut groundnuts? They contain good quantity of the oil. So these are the food which is containing good quantity of the oil. Rapeseed. So these are the cotton seed. They are the food article which are containing large quantity of the oil. The examples of the first generation fuel are ethanol, sugarcane, corn, wheat, biodiesel, soybean oil, sunflower oil, palm oil, bioethanol, and the molasses, which is coming from the sugarcane. Now, second generation biofuels are non-food. They are lignocellulosic sources. They are agriculture waste, forest residue, पत्ते गिर जाते हैं छोटे छोटे से. Non-food crop example, cellulosic ethanol, rice straw, uska husk of the rice, the wheat straw, the corn straw, bio oil, wood chips, lakdi ka jo chippa hota hai, is biofuels. Now, third generation algae based. Algae based fuels are the microalgae and macroalgae. Example, algal biodiesel, microalgae lipid extraction, algal bioethanol, seaweed fermentation, algal biogas, and coming out of the anaerobic digestion of algal biojet fuels, and the high lipid algae. So these are the algae based fuels. The algae usually is converted into lipid, that is triglyceride, in the presence of sun rays and carbon dioxide. So it is converted into triglycerides. So this is the source of triglycerides. This is a part of lipid, are the source of fuel. So fourth generation are the new biofuels, which are synthetic carbon negative, new word, carbon positive, carbon negative sources, genetically engineered organisms, carbon capture example, and then the syngases, the synthetic hydrogen gases, and syn biogases, genetically engineered fuels, biohydrogen, the hydrogen which is not made out of the chemical processes, the hydrogen which is a product of the organic process, is biohydrogen. We are not getting the hydrogen by the chemical reaction or by disintegration of water, but we are getting it with the help of the with the help of the bacteria, maybe algae, maybe some other type of the biological activity. So that is the fourth generation, that is synthetic carbon negative sources, which are most useful. Next is the Indian biofuel policy. What is the Indian government is giving the policy of the biofuel? So the objectives of the policy, the Indian government has decided this policy was given in 2018, and talk about 6-7 highlights of this policy, because all the research work is based upon the policy of the government itself, and what government is willing, what is going to happen in this country, accordingly the research work is taken up. Like the first objective of this policy is to reduce India's dependence on imported oil. So this is a prime most concern. We don't want the imported oil much in quantity. We wish our own developed, our own produced fuel oil should be used as much as possible, so that we can save the foreign currency. The objective of the policy is to promote clean and renewable energy, to promote the use of the clean and renewable form of the energy. Third objective of this policy is to use waste and surplus biomass for fuel. The waste, otherwise the sawdust, this type of things which are already going to waste, has to be used for making the fuels, and the surplus biomass for fuel. Waste and surplus biomass for fuel, the third point. The fourth point is the additional income to farmers. All the which has to be taken up in order to achieve one goal, that the farmer should get additional income in some way or other way. Now this is the first point. Second point is a major biofuel covered. But what type of biofuel this government is going to encourage is the ethanol biodiesel, bio CNG, compressed biogas, drop-in fuel, the biojet and the bio naphtha, and biohydrogen. These are the fuels which will be recommended. The third point is ethanol blending program. The EP, this is called EBT target. Now, everybody knows, आप सब जानते हो कि 20% इथेनॉल को पेट्रोल में मिला करके ही बेच रहे हैं आजकल. This is happening in this day-to-day life. It is happening. 20% ethanol blending is done in petrol. The allow ethanol production. Now, ethanol production को government ने allow किया है. किस method से किया है? Sugar cane juice. With the help of sugar cane juice, ethanol बन जाता है उससे. Then B molasses. B molasses. What is B molasses? And what is C molasses? And what is A molasses? The three type of the molasses are there. The A molasses, B molasses, and C molasses. The A molasses is the sugar cane is crystallized first, and the sugar is removed, and the leftover thing is called A molasses. Then again the sugar from the A molasses, the sugar cane is again sugars are again crystallized in the second stage. Again sugar is made, and then leftover is called B molasses. And third time when the crystallization takes place, and then the crystallization takes place, and then the leftover molasses is called C molasses. So these three type of the molasses are obtained with the help of the sugar cane, and they are different in the way that A molasses is having the best quality because of the large content of the sucrose, and B molasses in comparison to the B and C molasses because the sugar molasses is less. So A molasses can be used for eating purpose, but B and C molasses are hardly used for eating purpose. So they are used for making the ethanol. The damaged food grains, the food grains which have got damaged, eaten by the mice and the other animals, or maybe some damage because of some sort of a problem. The surplus rice and the wheat, the government buffer stock, which is already government has got. So you converting them into the ethanol. Then fourth point is stock allowed for biodiesel production. The government has allowed the feed stock for the biodiesel production. तो कौन सा feed stock allow किया government ने? Forestry waste, जंगल का waste है. Agriculture reduce, पराली जिसको बोलते हैं, कई जगह बन भी रहा है, वो पराली से अल्कोहल बना रहे हैं. Municipal solid waste जो नगर निगम का है. Industrial waste जो हमारा औद्योगिक वेस्ट है वो. नॉन एडिबल ऑयल सीड, जत्रोपानीम एटसेट्रा, इनको जो खाने योग्य नहीं है उनको भी हम इसमें यूज करते हैं. Then key importance over the earlier policy, how this policy is different from the earlier government policy. Wider feed stock allowed, ज़्यादा आप यूज कर सकते हो, ज़्यादा बना सकते हो. Viability gap between the 2G ethanol and the for the 2G ethanol plants here. So the second generation ethanol के ऊपर में viability gap funding, तो कैसे हम ये कोशिश करते हैं कि हमारा 4G इथेनॉल हमको मिल जाए, जिससे कि हम 2G इथेनॉल के ऊपर हमारी डिपेंडेंस कम हो. GST reduction on biofuel, government has reduced the GST on the biofuel, assured price mechanism for ethanol. So these are the 4 points government has taken over there. Now biodiesel focus, promotion of used cooking oil. They're trying to use the used cooking oil, leftover oils they're using. After multiple frying operation, the oil becomes black and it is bad for the health. So this used oil is used as for production of the biodiesel, and this is the government is supporting it. Collection support for non-edible oil plantation on wasteland. So government is doing the collection support for the non-edible oil plantation on the wasteland. The seventh point is waste to fuel program. Now waste to fuel program is connected in a way that government is giving incentive for covering waste to bio-CNG, bioethanol and biodiesel. Lastly, the most important point is that government is supporting proposed across all over India. So these are the points which has to be taken up. Now we have talked enough of the biomass. Now from biomass we shift to the second biofuel, that is biogas. Now biogas, I'll be talking. Biogas is a product of fermentation of the man and the animal's biological activity, waste products with bacteria degradation, biological material in the absence of oxygen, in a process known as anaerobic digestion. The biomaterial is decayed in the absence of oxygen, and when it is decaying, it gives a gas which is the result of fermentation. The fermentation is called anaerobic digestion process, which is a chemical process, and this process gives us the biogas. And this biogas is a fuel gas. It is having maximum large amount of methane, and this is the fuel quality of the biogas. Biogas contain 50 to 70% methane, 2% of hydrogen, and up to 30% of carbon dioxide. After being cleaning of the carbon dioxide, this gas becomes a fairly homogeneous fuel containing 80% of the methane. 80% of the methane is a good amount, and it becomes the very good fuel for the any of the purpose here. Now the capacity of this fuel is about 25 megajoule per meter cube. इसकी जो calorific value है वो 25 megajoule per meter cube हो जाती है, which is a very good fuel value. The most important component of the biogas from the calorific point of view is the methane, which is a cleaner fuel. Methane is considered the cleanest fuel because being fuel, single C fuel is the most clean fuel. Biogas dates as back as the 16th century when it was used by heating bath water in Persia. So this is the one of the biogas plant which I have shown, a very popular one. The toilet and this toilet over here, and this is digester plant over there, where the from the inlet this the human excreta and animal excreta is mixed with the water and stirred with the help of the stirrer or placed. I have got a small film for you people. So let us play this as film. So you will see the formation of the biogas. I like it's very old thing, but let us see that how it's an animation which shows that.
About biogas plant. The plant has a dome-like structure built with bricks, an inlet valve, and an outlet valve. It has a gas chamber
sorry,
that
sorry.
has no oxygen. Pour the slurry
उसको click कर
and water into the gas chamber.
यार आपसे
Gas
कुछ नहीं
is produced by the anaerobic microorganisms that do not require oxygen to decompose or break down complex compounds of the cow dung slurry.
वॉइस दीजिए उसको. अच्छा वॉइस नहीं है. So this is the basically I should tell. Play कर लीजिए ना. ये this is the place from here. This like human excreta and animal excreta is mixed with the water, and this slurry goes into this digester. Here it is decomposing. The slurry decomposes here, and after decomposition and anaerobic digestion, the gas stores here. Then it's coming out and it's used for various purposes. Maybe for the purpose of cooking the food, or maybe for the any purpose can be used. The leftover slurry is used as a manure for the agricultural purpose. So this is very common and everybody is using. So now, but even then, this is connected to the us. We can use this for the as a fuel in the engine. Our focus is to use it as a fuel in engine and convert the engine, change the hardware of the engine so that the this can be used for the existing diesel and the petrol engine. Me. So this is the Deen Bandhu model and all this thing. आगे बढ़ाइए और अच्छा मैं बढ़ाता हूँ ये नहीं ये this is one. Now methane, this is the composition of the typical biogas sample which is mentioned. I have already discussed about this composition. Now next slide gives the thermodynamic properties, which is important. Specific heat is 2165 kilojoule per kg degree Kelvin. The molar mass is this, density is equal to this much, individual gas constant is this much, and lower calorific value is also mentioned over here. Now next is the connection to the array bhai. Yes. Next is the modification of IC engine into gas diesel engine. So now we'll be discussing about how the existing diesel and petrol engine can be modified so they can run with the help of the biogas or maybe biodiesel or any of the biofuel. Maybe it is biogas, maybe biodiesel, whatever fuel is there. How to modify engine. So diesel engine, first of all, I'm taking diesel engine, then I'll discuss about petrol engine. Both the engines I'll talk. Diesel engine can be modified to operate on biogas in two different ways. Number one, dual fuel operation with ignition by pilot fuel injection. Dual fuel operation with ignition by pilot fuel injection means the pilot fuel is injected and then the another fuel, the biogas, maybe it is biogas, then it is mixed with the air, and the injection is done. Injection of the diesel or biodiesel is done. So this is there. So in this case, the normal diesel fuel injection system will still supplies a certain amount of diesel fuel. Pilot fuel injection करेंगे, थोड़ा सा हमारा normal जो injector लगा है, fuel pump लगा है और nozzle लगा है, वो रहेगा उसमें, और वो वहाँ पे हम begin करेंगे diesel की, वहाँ से diesel का उसमें spray होगा. The engine, however, sucks and compresses a mixture of air and biogas. The diesel engine है, तो air के बदले वहाँ पे हम उसमें भेजेंगे air और biogas का mixture. The air and biogas mixture will be sent, and the pilot fuel injection, the diesel fuel, diesel or biodiesel, both can be injected. So this can be, the mixture is then ignited by spray of diesel fuel through the nozzle, either diesel or biodiesel, both can be injected. The amount of diesel fuel needed for sufficient ignition is between 10 to 20%. I mean 10 to 20% only diesel will serve this purpose. 80 to 90% will be biogas. So this is a very big thing. There's a big saving in the diesel or biodiesel, both. The amount needed for operation on diesel fuel alone, operation of the engine on partial load requires reduction of the biogas supply by means of the gas control valve. So control valves are there which can change the quantity of the biogas which is being supplied. Diesel can be replaced by neat biodiesel or biodiesel blends. ये मैंने आपको पहले बताया था कि डीजल का इंजेक्शन के बदले हम वहाँ पे बायोडीजल या बायोडीजल डीजल का ब्लेंड भी हम वहाँ पे यूज कर सकते हैं. So this is the one thing. Second point, simultaneous reduction of the airflow would reduce power and efficiency because of reduction of the compression pressure and mean effective pressure. ये थोड़ा सा हमको compression pressure और mean effective pressure में reduction करना पड़ेगा. So the fuel air ratio is changed by different amount of injected biogas. All other parameters and elements of diesel engine remains unchanged. थोड़ा सा दो चीजें चेंज करते हैं, compression pressure और mean effective pressure थोड़ा सा चेंज करते हैं. Now diesel fuel engine has following advantages. Dual fuel engine has following क्या क्या advantages है? Operation on dual fuel alone is, हम चाहे तो सिर्फ डीजल पे चला लो, आपका मन तो बायोगैस दे लो. When biogas is not available, जब बायोगैस नहीं है हमारे पास में तो हम डीजल पे चला लें. दूसरा पॉइंट, any contribution of biogas from 0 to 85%, जितना भी आपके अवेलेबल है 0%, लेके 85% तक आप बायोगैस दे दीजिए, अब बाकी का जो है ब्लेंडिंग हो जाएगी उसके साथ में, वो पायलट फ्यूल इंजेक्शन में 15% 20% तक आप उसमें डीजल या बायोडीजल कर सकते हो। तो ये 100% डीजल ऑपरेशन पे भी काम करेगा। बिकॉज ऑफ एग्जिस्टेंस ऑफ ए गवर्नर और मोस्ट डीजल इंजन, ऑटोमेटिक कंट्रोल ऑफ स्पीड एंड पावर कैन बी डन बाय चेंजिंग द अमाउंट ऑफ डीजल फ्यूल इंजेक्शन while the biogas flow remains uncontrolled. Diesel fuel substitution by biogas are less substantial in this case here. इसके लिमिटेशंस हैं, लिमिटेशंस इसके हैं, ड्यूल फ्यूल इंजन कैन नॉट ऑपरेट विदाउट द सप्लाई ऑफ डीजल और बायोडीजल फ्यूल इंजेक्शन। ये बिना उसके काम नहीं करेगा, अकेले बायोगैस पे काम नहीं करता है क्योंकि इट्स ड्यूल फ्यूल इंजन, एक ही बार में हम 2 फ्यूल यूज कर रहे हैं, उसको हम ड्यूल फ्यूल इंजन बोलते हैं। तो ये विदाउट सप्लाई ऑफ डीजल और बायोडीजल ये काम नहीं करेगा। द फ्यूल इंजेक्शन जेट्स में ओवरहीट when the diesel fuel is reduced to 10 to 15%, जब हम डीजल का अमाउंट 10 से 15% करते हैं तो उसमें इंजेक्शन फ्यूल इंजेक्शन की ओवर हीटिंग हो सकती है, जो हमारे इंजेक्टर्स को नोजल्स को थोड़ा सा प्रॉब्लम उसमें हो सकता है। तो ये 2 छोटी छोटी प्रॉब्लम्स हैं। इसके सिवा एक और है, दूसरा एक और पॉइंट है, अब हम डीजल को गैस ऑटो इंजन में कन्वर्ट कर रहे हैं। मॉडिफिकेशन ऑफ डीजल इंजन टू गैस ऑटो इंजन, आई मीन डीजल इंजन को हम गैस ऑटो इंजन में जैसे पेट्रोल इंजन की तरह चलाने की कोशिश कर रहे हैं। इस वाले पॉइंट पे मेरे को एक पेटेंट भी मिला, रिसर्च स्कॉलर था, उसने इस पे पीएचडी किया है, हमारी लैब में किया है, और मैं आपको पेटेंट दिखाऊंगा। मैंने इसमें प्रेजेंटेशन में पेटेंट भी दिया है। एक मिक्सर डिजाइन किया था और वो मिक्सर को पेटेंट अवार्ड हुआ है। तो उसमें अब कैसे करते देखिए, ये पॉइंट कैसे होता है। रिमूवल ऑफ इंजेक्टर पंप एंड इंजेक्टर नोजल, इंजेक्टर पंप और नोजल निकाल दिया। रिडक्शन ऑफ द कॉम्प्रेशन रेशियो टू 10 to 12। अब ये कॉम्प्रेशन रेशियो रिजेक्ट आपको चेंज करने के लिए कुछ नहीं करना पड़ता, पिस्टन हेड का पिस्टन हेड मूवेबल होता है। देयर आर सम इंजन वेयर द पिस्टन हेड इज मूवेबल, क्लियरेंस वॉल्यूम को अल्टर करके हम कॉम्प्रेशन रेशियो को चेंज करते हैं। तो ये आपको चेंज करना पड़ेगा, कंप्रेशन रेशियो जहां 20-22 है तो उसको 10 से 12 पे लाना पड़ेगा, ये एक चेंज है। माउंटिंग ऑफ एन इग्निशन सिस्टम पूरा लगाना पड़ेगा। डिस्ट्रीब्यूशन, डिस्ट्रीब्यूटर, बैटरी, इग्निशन कॉइल, स्पार्क प्लग, इलेक्ट्रिकल सप्लाई, मतलब वो पूरा का पूरा हमारा बैटरी सिस्टम, इग्निशन कॉइल, इंडक्शन कॉइल, डिस्ट्रीब्यूटर और ये पूरा लगा है। तो ये पूरा सिस्टम बिना उसके से ऑटो इंजन में कन्वर्ट होगा। ये तो वो आप निकाल रहे हो तो ये लगा भी रहे हो। इसके बाद में तीसरा पॉइंट है प्रोविजन ऑफ मिक्सिंग डिवाइस फॉर द सप्लाई ऑफ एयर फ्यूल मिक्सचर। अब मिक्सिंग डिवाइस कैसी चाहिए, जो कि एयर और मतलब आपको गैस के साथ में फ्यूल को मिलाना है, तो पहले वो फ्यूल को एटमाइजेशन करे और फिर उसके साथ गैस को मिलाए विद द कांस्टेंट एयर फ्यूल रेशियो, वेंचुरी मिक्सर और न्यूमेटिक कंट्रोल वाल्व। ये मिक्सर हम लोगों ने डिजाइन किया था और इसके ऊपर एक पेटेंट हमको ग्रांट हो चुका है। मैं खुद उसके इंटरव्यू में बैठा था और हमने वहां पर उसको प्रोटेक्ट किया था, उसको डिफेंस किया था हमने। तो ये जो पेटेंट मैंने आपके लिए लाया भी हूँ, ये पेटेंट का कॉपी, ये पेटेंट की कॉपी है और ये एक उसका पेपर एससीआई पब्लिकेशन था उसका, और पीएचडी अवार्ड हो गया उसके उस जो कैंडिडेट था उसको, ये अवार्डेड पेटेंट है। तो ये मिक्सर के डिजाइन के ऊपर है। एक और बायोगैस प्लांट का फोटो है, एक देखिए आप, ये हमने एक और तो उसके लिए हमने एक छोटा सा बायोगैस प्लांट खरीदा था, परचेस किया था। ये एक बड़े से ड्रम में एक छोटा सा ड्रम, उसमें एक फ्लोटिंग चैम्बर के रूप में डाला हुआ है, ये है इसमें। और मैं आपको बताता हूँ, ये एक बड़ा सा ड्रम है, ये इसमें स्लरी डालते हैं और इसमें स्लरी यूज करते हैं। जो हमारी यूनिवर्सिटी के मैथ्स में जो स्टूडेंट्स का लेफ्ट ओवर फूड था, तो 1.5 से 2 किलो की उसमें स्लरी लेफ्ट ओवर फूड की रोज का लगता था। और उसको चालू करने के लिए 150 किलो टू बिगिन विथ 150 किलो गोबर लगाते थे उसमें। 150 किलो गोबर से चालू होता था, लेकिन रोज 150 किलो गोबर नहीं लगता था, रोज अपन उसमें केवल 1.5 से 2 किलो उसमें डालते थे लेफ्ट ओवर फूड, मतलब जो बचा हुआ खाना, बच्चों का जूठा होता था वो, और जो सब्जी के कतरने, किचन से निकलती हैं, छिलटे वगैरह सब्जी के, तो वो सारे के सारे डाल के यहाँ से स्लरी बना के पानी में डालते थे। और ये होल्डर है, इसमें ये ऊपर उठता था, इसको ऊपर उठ के ऊपर न चल जाए तो उसको हम लोगों ने ऐसा वेट लगा के उसको ये रखा था कि ये ऊपर ना चला जाए बहुत ज्यादा। और यहाँ से गैस हमको मिल जाती थी, तो हम इसको टायर ट्यूबों में भर के और इंजन के पास जाके इंजन के साथ मिक्स करके उसको इंजन को चलाते थे। इस पे एक और दूसरा पीएचडी था मेरा, वो उसके ऊपर एक दूसरी पीएचडी अवार्डेड है इसके, और ये 25,000 रुपए का था। थोड़ा दिन हो गया इसको, 5-7 साल हो गए लिए हुए। उस समय इसकी कीमत केवल 25,000 थी। और वो जो आदमी देता था उसको हम लोगों ने बहुत तंग किया और उसको बहुत मुश्किल से पेमेंट किया, लेकिन उससे सब काम करवाया कि तुम करवा के बताओ, पूरा बना के बताओ, ये वो, तब ये कर दिया था पेमेंट, ऐसा नहीं। लेकिन बाद में उसको पूरा उससे व्यवस्थित उससे वर्किंग कराया। लेकिन ये प्लास्टिक का तो सब लीकेज हो गया, सब प्लास्टिक का था, वो पोर्टेबल है, कहीं भी उठा के रख सकते थे, बड़ा सा टैंक है। तो इसकी कैपेसिटी बहुत कम थी। ये एक दिन में 1 मीटर क्यूब पर डे 1 मीटर क्यूब गैस देता था, बायोगैस। और इसका सब डिटेल, टेक्निकल डिटेल मैंने यहाँ लिखा है, कितना पानी लगता है, कितना इसमें, कितना हमको ऑर्गेनिक मैन्योर मिल जाता है। ऐसे मैन्योर भी मिलता था इसको बाद में, इसके नीचे की जो बचा खुचा था वो गैस बनाने के बाद में उसको हम लोग एज ए मैन्योर भी निकाल के यूज करते थे। तो वो भी था, तो इसको यूज किया है और इस पे काम किया है। ये देखिए, ये इसको यूज करके जो अलग अलग प्रपोर्शन में हमने, ये अलग अलग ग्राफ हैं जो अलग अलग प्रपोर्शंस के बने हुए हैं। और देखिए आप 50% लोड, ये फुल लोड 12 kg है, तो 6 पे जो है 50% लोड है, 50% लोड पे मैक्सिमम डीजल सेविंग मिल रही है हमको। ये एक छोटा सा ग्राफ मैंने आपके लिया हुआ था। 50% लोड पे हमको 50% द फुल लोड पे वी गेट द मैक्सिमम सेविंग इन द diesel fuel, dual fuel operation में, in the dual fuel operation we get this result. So this is the result. Now this again few pictures which are connected to the अभी याद रखिएगा, हमने पेट्रोल इंजन को नहीं कन्वर्ट किया है गैस इंजन में, अभी सिर्फ डीजल इंजन को दो तरह से मैंने बताया। अभी अगली स्लाइड्स में मैं आपको पेट्रोल इंजन का कन्वर्शन भी बताऊंगा और उसके ऊपर भी बहुत सारा काम है। This all research works only which were conducted in real research works. Performance and operation parameters. Performance and operation parameters के, अब ये gas obtained from 100 kg of the waste can fuel a medium size car up to 100 किलोमीटर। मतलब देखिए, मतलब थोड़ा सा प्रॉब्लम तो है ही, 100 kg आपको मास लग रहा है, जिससे कार आपकी चल रही है 100 किलोमीटर, तो इतना ज्यादा मतलब मास हमको लग रहा है, बायोमास। तो थोड़ा सा ये मतलब ठीक है, पर अभी इसके वायबिलिटी में थोड़ा सा, इसको पोर्टेबिलिटी में इसको यूज अभी भी नहीं कर पा रहे हैं, क्योंकि मूविंग व्हीकल्स में इसका यूज नहीं हो पा। द परफॉर्मेंस ऑफ डीजल गैस इंजन इज ड्यूल फ्यूल मोड हैज बीन फाउंड टू बी ऑलमोस्ट इक्वल टू परफॉर्मेंस यूजिंग डीजल फ्यूल अलोन, एज लॉन्ग एज कैलोरीफिक वैल्यू ऑफ द बायोगैस इज नॉट टू लो। ये कैलोरीफिक वैल्यू लो कैसे होगी? कैलोरीफिक वैल्यू लो ऐसे होगी कि उसमें कार्बन डाइऑक्साइड परसेंटेज ज्यादा रहेगा, जैसे और मीथेन परसेंटेज कम रहेगा। तो करते क्या है, रिफाइन करते हैं, गैस का सैंपल मिला, उसमें से कार्बन डाइऑक्साइड को निकाल देते हैं बहुत सारा, जिससे उस पे कॉन्सेंट्रेशन मीथेन का बढ़ जाता है। मीथेन के कॉन्सेंट्रेशन बढ़ने से कैलोरीफिक वैल्यू इंप्रूव हो जाती है। तो दिस इज व्हाट ये ऑपरेशन करना पड़ता है। तो वो अपन अपने लेवल पे नहीं कर पा सकते हैं, इसके लिए मैकेनिज्म चाहिए और थोड़ा सा उसके लिए एडवांस सिस्टम चाहिए। तो वो एक क्लीनिंग का भी प्रॉब्लम रहता है। जो सीधा सैंपल से मिलता है उसमें मीथेन का परसेंट, कार्बन डाइऑक्साइड 30% के करीब रहती है। कोशिश ये करते हैं कि उसको 10% 15% पे ले आए। द गैस ऑटो इंजन, अब ये वाली बात आई कि हाउ टू यूज द पेट्रोल इंजन for the sake of the dual fuel mode and other things here. The modification of an auto engine is petrol engine, is comparatively easy, as the engine is designed to operate on an air fuel mixture with spark ignition. The basic modification is the provision of air gas mixture instead of carburetor. अब कुछ नहीं करना है, कार्बोरेटर को हटा के एक मिक्सर डालना है उसमें, जो मिक्सर हमको सही प्रोपोर्शन में गैस के साथ में एयर को मिला के दे दे। तो ये अपन लोग करते हैं, किट्स आती हैं आजकल, तो रेडीमेड किट्स आती हैं, और गवर्नमेंट तो आजकल बना, मतलब कंपनियां तो बनाई के बेच रही हैं। हमारे पास सीएनजी कारें आ रही, वही सीएनजी भी क्या है, वही है, मीथेन ही है। तो वही है, बायोगैस मीथेन सीएनजी का थोड़ा सा कम ग्रेड वाला फॉर्म है, क्योंकि उसमें मीथेन का परसेंटेज थोड़ा कम होता है। सीएनजी में 70 से 75-80% तक होता है, जबकि इसमें 50 से 70% होता है। तो थोड़ा सा इसमें मीथेन का परसेंटेज कम होता है। उसको यदि सीव आउट किया जाए तो यू कैन एनरिच इट। The engine control is performed by variation of the mixture supply. इंजन का कंट्रोल मिक्सचर सप्लाई, मिक्सचर ज्यादा भेजेंगे तो इंजन को पावर ज्यादा मिलेगा, मिक्सचर कम करेंगे तो पावर कम मिलेगा। The increase in compression ratio appears to be desirable as it provides an increase of the process from the thermodynamic point of view. तो compression ratio थोड़ा सा हमको increase करना पड़ता है। Lower specific fuel consumption and higher power output can be expected with the drop in the with the increase in the compression ratio. The modification is permanent and prevents using of original fuel. लेकिन जो modification हम कर रहे हैं उससे ये इंजन किसी भी प्रकार पेट्रोल केवल पे काम नहीं कर पाएगा, वो केवल ड्यूल फ्यूल मोड पे ही काम कर पाएगा। तो ये एक इसका थोड़ा सा हल्का सा नुकसान है, क्योंकि अर्लियर जो डीजल वाला बताया था मैंने उसमें ये था कि वो 0% गैस पे भी काम करके प्योर डीजल पे भी काम करता था। ये प्योर डीजल प्योर पेट्रोल पे काम नहीं कर पाएगा। An increase in the compression, ये हो गया। The adjustment of the point of ignition in the relation to slow burning velocity of the biogas imposes no specific problem. थोड़ा सा इग्निशन भी स्लो है गैस का, पेट्रोल की तुलना में तो गैस को हम क्या ही बोलें, इट्स ए पुअर फ्यूल, पेट्रोल इज अ वेरी गुड क्वालिटी फ्यूल। तो इग्निशन भी इसका स्लो होता है और इसका स्लो बर्निंग वेलोसिटी SU burning velocity is little bit slow in comparison to petrol fuel. Burning velocity slow होने से flame propagation slow होगा और combustion process भी slow हो जाएगी। तो वो एक इसके साथ में है। ये system provides the adjustment in the sufficiently wide range, है ना। Engine which cannot operate on unleaded fuel will miss the lubrication effect of condensing lead. अब जो unleaded पेट्रोल पे काम कर रहे हैं इंजन, उसमें लुब्रिकेशन प्रॉब्लम भी आएगी, क्योंकि गैस आप डाल रहे हो तो उनमें थोड़ा सा लुब्रिकेशन प्रॉब्लम भी आ जाती है। तो ये इसके बारे में है। परफॉर्मेंस एंड ऑपरेशन पैरामीटर्स के ऊपर मैंने और लिखा है। बायोगैस ऑटो इंजन व्हेन मॉडिफाइड फ्रॉम ऑटो इंजन यूजिंग पेट्रोल फ्यूल आर फाउंड टू प्रोड्यूस लेस पावर than in petrol version, which is obvious that it will produce less power. This region is decrease in the volumetric efficiency as a gaseous fuel occupies a larger portion of the mixture volume sucked into the engine than liquid fuel and displaces air accordingly. So इसमें air का भी कम हो जाता है परसेंटेज, क्योंकि गैस ऑक्यूपाई कर लेती है एयर का क्वांटिटी। तो ऐसी स्थिति में इसका कम्बशन भी थोड़ा सा ऑक्सीजन की एब्सेंस में हल्का सा सफर करेगा। The liquid fuel has a higher volumetric energy contained than biogas and also cools the air fuel mixture when evaporates in intake manifold. The cooling effect, an increase in the density and hence the amount of the air fuel mixture actually sucked into the engine on the mass basis is higher. So this is another point which is connected to this. Now, biogas for vehicle challenges. Now, what are the challenges for using the biogas for the vehicles? The utilization of the biogas in the vehicle requires a method of compact storage. अब हमको कार में बायोगैस को यूज करके चलना है तो हमको उसको स्टोर करना पड़ेगा। कैसे करेंगे फिर? तो स्टोर करने के लिए कॉम्प्रेस लिक्विडिफिकेशन करना पड़ेगा। लिक्विडिफिकेशन करने के लिए हमको बहुत हाई प्रेशर पे उसको कॉम्प्रेस करना पड़ेगा, नंबर 1। नंबर 2, उसका प्रेशर वेसल बहुत स्ट्रॉन्ग लगेगा। हाई प्रेशर पे आप कॉम्प्रेस करोगे तो वेरी स्ट्रॉन्ग प्रेशर वेसल यू नीड टू स्टोर इट। तो ये बड़ा भारी महंगा प्लांट हमारे को लग जाता है इसके लिए। यू नीड a very costly plant for this purpose, a very costly plant for this purpose, because you have to compress it to the liquidification stage. And number 2, you have to make it, you have to use the very strong high pressure resistant capsule to store this. The larger quantity of the biogas can only be stored at small volume under high pressure. It is 200 to 300 bar. इतना pressure हमको चाहिए. As purified as methane in a liquid form at cryogenic condition. अब you have to liquidify the methane, so you need the cryogenic temperature, which is -161. Liquidification of the methane at such a lower temperature will be problematic. It's not easy to produce -161 degree temperature, and it will need a lot of expenditure. So very costly very costly plant, bottling plant जिसको बोलते हैं हम, we need bottling plant. Bottling plants are very costly, and it's not possible for the individual to set up the bottling plant. Only government is settling the bottling plant. हमारे घर में गैस का bottling plant हो, चाहे कोई भी bottling plant हो, it takes a lot of huge capital investment to set up the bottling plant. Huge capital investment to set up a bottling plant. Now, one cylinder of 50-liter volume can store a pressure of 200 bar, approximately 15 meter cube. एक 50 लीटर का सिलेंडर कैन स्टोर एट ए प्रेशर ऑफ 200 बार प्रेशर पे 15 मीटर क्यूब हमारी जो है वो अनप्यूरिफाइड बायोगैस ले सकता है विथ एन एनर्जी इक्विवेलेंट ऑफ 98 किलोवाट आवर सॉरी जिसका एनर्जी इक्विवेलेंट करीब 98 किलोवाट आवर है ऑफ डीजल फ्यूल और 13 मीटर क्यूब ऑफ प्यूरिफाइड बायोगैस with an energy equivalent of 125 kilowatt hour of diesel fuel. Yes, का है. The storage volume has required. This is giving the if we take a cylinder, then how much capacity of energy we are taking? How much amount of energy you are taking? The 50 liter of the cylinder, then how much energy portion you are taking portably with you in the form of the car? Even then, it's a limitation. So limitation is there because of the change. एक बार 100 किलोमीटर चले तो खत्म हो गया उसको फिर रिफिलिंग करने का सिस्टम चाहिए हमारे को so that you can refill it or you can again move. So this is again same problem with the EVs also now. The battery discharges, then you have to stop somewhere or get it charged, number one, or number two, get it swapped. So same thing. Now another option is the biodiesel option, boys. Biodiesel option is an old option. But this is biodiesel is also a biofuel. So my presentation is on the biofuel. So in addition to biomass and the biogas, I switched to third fuel, which is because the biofuel, after I have covered up all the biofuels, ranging from biomass to biogas and then biodiesel. All the biofuels are covered over here. So biodiesels, many type of the esters based upon the oxidized fuels, which are obtained from the various natural renewable bio sources like vegetable oil, etc. So advantages of the biodiesel, a lot of advantages. Should I read this or like the biodiesel is a popular fuel, so I skip this slide or should I read this? It's known to everybody. The sorry, it's known to everybody. So these are also advantages of the biodiesel. सबसे बड़ा एडवांटेज बायोडीजल का ये कि इट्स अ बायोफ्यूल. बायोफ्यूल का मतलब है it contains the oxygen into it. So when the fuel itself contains lot of portion of oxygen, then when it burns when it is burned, it takes the oxygen from outside and it has got its own oxygen which is dissolved in the fuel itself. So the burning efficiency, the calorific value improves, the combustion efficiency improves. All the carbon get oxidized into dioxide and all the hydrogen oxidized into the water vapor. So the combustion efficiency tremendously improved because of the oxygen content is enough or more than enough sometimes. The air is there and its own built up dissolved oxygen because biofuel. So that way it is a good fuel and environmentally it is good. So this is all about the biodiesel. Sources of biodiesel. Neem, Karanj, Kusum, Pilu. These are all Ratanjot, Mahua, Bhikul. These are so many, about more than 50, 60 sources are there from the nature, which are the sources of the biodiesel. Now, these are the property comparison of the diesel and biodiesel, property comparison. Look, the properties are matching. Look the density, they're matching densities. Carbon content is almost matching. Then sulfur is matching. Hydrogen is also matching. Flash point is, you can see the flash point is matching. C10 number is also agreement in sort of a 10-15% variation agreement. Stoichiometric fuel air ratio is also moreover matching. And you can see that the only one point which is carbon content is also, it is higher carbon content but somewhat matching one. So boiling point is also, you can see that it is matching the last one. So a lot of matching thermophysical properties are seen here. Now production and testing of the biodiesel. There's a short film here. इसको शायद इसको hyperlink को कर दीजिए. अच्छा इस पे नहीं है. हाँ ये है. हाँ.
Today I'm going to make biodiesel fuel from cooking oil and a few household ingredients. This project was really satisfying, and I think it's more accessible to the average person than most of what I do on this channel. To get started, all you have to do is add 1 part methanol to 5 parts oil and then toss in a little sodium or potassium hydroxide. As a side note, methanol can be purchased as a fuel system cleaner for your car, and sodium hydroxide is just strain cleaner. In any case, for this batch, I used 500 milliliters of oil, 100 milliliters of methanol, and 5 grams of sodium hydroxide. I then cooked the mixture at 80 degrees Celsius for 30 minutes to push the reaction to completion. This can also be done at lower heat over a longer period of time, but I'm pretty impatient. Now, what's happening here is a 2-step reaction that begins with the formation of sodium methoxide from sodium hydroxide and methanol. Sodium methoxide is extremely reactive, and in a second step, it'll react with the oil in what's called a transesterification reaction. To give you an idea of what's happening, fats are primarily composed of molecules called triglycerides, which are basically 3 fatty acid molecules bound to a glycerol. Sodium methoxide is basically able to tear these fatty acids off of glycerol and then bind themselves onto the carboxylic acid. This continues until all 3 fatty acids have been removed, leaving glycerol as a side product. Anyway, once the reaction is complete, I allow it to cool, filter off the sodium hydroxide, and transfer the filtrate to a large separatory funnel. This is allowed to sit overnight to allow all of the glycerol and solid impurities to settle to the bottom, while all of the biodiesel will stay on top. When I came back the next day, I found that the glycerol layer had solidified, and so it might be better to just decant it off to begin with and not bother with the separatory funnel. To this end, I went ahead and decanted my crude biodiesel out of my separatory funnel and then cleaned it thoroughly. I then returned my crude biodiesel back to my separatory funnel to begin the washing process. For the washing process, I basically want to remove any water-soluble impurities from my biodiesel, and this is done by adding an equal volume of water to my crude biodiesel and shaking thoroughly in the separatory funnel. The water layer containing any impurities will settle to the bottom where it can be drained away and discarded. This is repeated 3 times until the water layer runs clear, and then I do a 4th and final rinse using saturated sodium chloride.
ये बंद कर दीजिएगा. So this is the production in nutshell. Presentation. हाँ. Yeah, this is the plant which is there in our university. Now this particular column, which is a chamber, it is housing the oil, any of the oil, like whatever oil you want to use it, some oil is there. Now from this chamber, the oil is pumped to this mixing chamber. Here the oil is mixed with the like you take 1 liter of the 1 liter of the oil, any oil, and you have to mix about 100 ml of alcohol, either ethyl or methyl alcohol, and then 1 ml of NaOH or KOH as catalyst. These 3 things are kept inside this, and this is heated up for about 60 to 80 degrees centigrade for 2 hours. When it is heated up for 2 hours, the chemical reaction of transesterification takes place, and the glycerine is formed. Glycerine is formed, and this glycerine is precipitated at the bottom, which is sieved out from here, and the upper layer is the biodiesel. And this upper layer is pumped over here. This is in this chamber the biodiesel is stored. Now in this chamber some water is poured in from the top side, and the water is used to wash the whole the water plus biodiesel mixture, so that extra water can be removed and you get the pure biodiesel coming from this thing here. So this is what the biodiesel is produced with the help of this particular plant. And I have explained the now this is the preparation method which is given in this slide, which is not of much use because I have narrated myself the whole process. Now this one engine is there. We had the computer control diesel engine, which we have used with biodiesel and the biodiesel blends, and we have plotted some performance parameters with the help of this engine. These are simple curves which are plotted, like brake power versus mechanical efficiency. Simple curve. These are something like brake power versus mechanical for different blends and for different things. Now this one, the last one, this is all so many mechanical efficiency, biodiesel, mechanical linseed oil. Now here the three oils are compared, the mechanical efficiency versus the brake power. With the three oils are biodiesel, diesel and the straight vegetable oil. This curve is giving three straight vegetable, another biofuel. Without converting it to the biodiesel, the fuel is used over here is the vegetable oil. We are not converting the vegetable oil into the fuel, directly using the vegetable oil into the engine as fuel. So that is another fourth type of the biofuel which were used here. So this is the all about this slide. Now the second slide is also I have to run all this. Yeah, this one. Now this slide is again brake power versus volumetric efficiency. Volumetric efficiency is giving us the concept of how much volume is being utilized by the fuel. The engine volume is utilization. It gives about the engine volume utilization. It's a UV 90 to 90 plus percentage form. It comes in the 90 plus. These are some comments are there on to this. And the last fifth fuel which I'll be talking is the straight vegetable oil, SVO, which I said that during the course of literature survey, I came across SVO, the straight vegetable oil, without converting it into any of other fuels. सीधा खाने का तेल डाल दिया. कई बार ऐसा होता है कि मिलिट्री ऑप्शन में, खास करके जैसे राजस्थान बॉर्डर पे पाकिस्तान के साथ में वॉर चल रहा है, तो ऐसी स्थिति में क्या होता है, वहाँ डीजल के पंप नहीं होते, गांव है, तो वहाँ डीजल एकदम ही खत्म हो गया, उनके कंटेनर में भी खत्म हो गया, तो गांव की किसी दुकान से मूंगफली का तेल खरीद के उसमें डाल दिया और सीधा मूंगफली का तेल उसमें जला के इंजन को हमने गाड़ी को 5-10 किलोमीटर चला लिया. तो ऐसे ऑप्शन बहुत ज्यादा यूजफुल होते हैं कि सीधा विदाउट. लेकिन इसमें सबसे इम्पोर्टेंट ये है कि हमने जब इसको चलाया था तो वो सीधे इस ऑयल पे स्टार्ट नहीं होता है. It doesn't start with the vegetable oil. You have to start it with the diesel or biodiesel and then you have to shift it to the vegetable oil. Then वो चल जाता है खड़खड़ करके 10-5 किलोमीटर चल जाएगा. अदरवाइज वो बहुत ज्यादा कंफर्टेबली नहीं चल पाता है, लेकिन फिर भी इट इज इमरजेंसी वायबल फ्यूल which is recommended here. Now these are the different comparison with the biodiesel versus the straight vegetable oil comparison. Now we can see this comparison. Now after using the this biodiesel and vegetable oils for the how this engine piston and hub piston, I mean the cylinder piston, this is the piston, these are the injectors and the nozzles, how they look like. A lot of carbonous deposit can be seen on that onto the machine parts. Lot of carbon deposit, excessive carbon deposit is seen. There is a trend to use biogas and petrol and diesel engine in dual fuel mode. The experimental performance studies are progress to run the engine in dual fuel mode with slight alteration in the hardware. ये मैंने आपको बता दिया है क्या-क्या experimentations हैं dual fuel mode का operation, changes in the hardware. Without change in the hardware of the engine, the biodiesel can be used to alternate automotive fuel in CI engines. All the biofuels produce less emission than the fossil fuel and portray better combustion characteristics. तो ये एक इसके वेजिटेबल ऑयल का ऑप्शन के बारे में बात किया है. अब चैलेंजेस की बात करेंगे हम, जो चैलेंजेस हमारे यहाँ हैं जो बायोफ्यूल यूज करने में. 3 बेसिक चैलेंजेस को हमने डिस्कस करा है. एक तो हाई प्रोडक्शन कॉस्ट है, which is a very inevitable. Biofuel production technology, especially 2G and 3G fuel. 2G और 3G fuel मैंने आपको बताया था. 2G is non-food grade fuel और 3G is the algae based fuels हैं. It's still very expensive due to the costly enzymes, advanced reactors and low processes efficiency. Setting up a biorefinery requires high capital investment, making biofuel more expensive than the petrol or the diesel unless supported by the subsidies. ये गवर्नमेंट का प्रॉब्लम है, थोड़ा सा हमको ज़्यादा इसमें प्रोडक्शन कॉस्ट लगती है. दूसरे नंबर पे है फीड स्टॉक लिमिटेशंस. हमारे पास में रॉ मटेरियल तो फीड स्टॉक का लिमिटेशंस है. Reliable and the continuous availability of the biomass such as crop residue, non-edible oil seeds or algae is difficult. Feedstock supply varies due to the seasonal crops. सीजनल क्रॉप्स होती हैं, क्रॉप्स कट के आएंगी तो बहुत सा हमको मिल जाएगा, क्रॉप्स नहीं है तो हमको स्टॉक का अवेलेबिलिटी की प्रॉब्लम हो जाती है. तो हाई ट्रांसपोर्टेशन कॉस्ट है, बाकी जगह आपको ट्रांसपोर्ट करना पड़ेगा, ट्रांसपोर्टेशन कॉस्ट इज हाई, सो दिस इज अनदर प्रॉब्लम. दिस मेक्स लार्ज स्केल बायोफ्यूल प्रोडक्ट. गवर्नमेंट की जब देखो, जब पॉलिसी चेंज होती है और उससे यूनिफॉर्म पॉलिसी नहीं होने से हमको इनकंसिस्टेंसी होती है, यूज करती है नहीं करती है वो भी आपस में यदि थोड़ा सा डिफरेंस ऑफ ओपिनियन है तो कई बार जो पॉलिसी लेट डाउन है सेंट्रल गवर्नमेंट की वो स्टेट गवर्नमेंट्स नहीं अडॉप्ट करती हैं तो अपने हिसाब से कुछ भी चेंज करके अडॉप्ट करती है. पॉलिसी इनकंसिस्टेंसी इज अ बिग the biofuel. Biofuel policy often face delay in the implementation, frequent rule changes, lack and uniform standard across the state. मैंने ये सब बातें आपको बताई हैं. This create uncertainty of investors and industries, slow down the growth of the large scale biofuels. So this is there. Now next is the future technologies की बातें करेंगे हम. Biofuels के केस में 3 new type of the biofuel future technology fuels are coming up. One is the algal bioreactors, biohydrogen and synthetic fuels. So I will talk all these 3 biofuels in little bit detail. The algal bioreactors, अब मैं इसके बारे में बताऊं आपको. Algal bioreactors is nothing. Algae, the algae and fungi. Algae जो हरा हरा हमारे पास में काई बन जाता है ना, that is algae. हरी रंग की काई बन जाती है, जैसे हम उस पे चलेंगे तो फिसल के गिर जाएंगे, बरसात में जगह जगह काई लग जाती है, that is algae. उस algae को sun rays and कार्बन डाइऑक्साइड, 2 चीजों के प्रेजेंस में उसको केमिकल रिएक्शंस टेक प्लेस होते हैं और वहां पे ट्राइग्लिसराइड्स बन जाता है. ट्राइग्लिसराइड इज अ फ्यूल. इट्स अ लिपिड कंपोनेंट which is a fuel, which is having the calorific value and it burns. It is having the calorific value and it burns. So triglyceride is a fuel and this burns. And इसके bioreactor is an instrument which is using the algae in presence of sunlight and in presence of carbon dioxide. अब कार्बन डाइऑक्साइड कैसे मिलेगी, तो बहुत, ये तो खुशी की बात है कि आप कार्बन डाइऑक्साइड यूज कर रहे हो. आप जहां पे बॉयलर है, बॉयलर का पूरा जो चिमनी का धुआं है वो इस पे भेज दो आप, वो एल्गी के साथ रिएक्ट करके जो है आपको ट्राइग्लिसराइड बना के देगी. ट्राइग्लिसराइड इज ए फ्यूल. आपको लिपिड का कंपोनेंट मिल रहा है जो आप जला सकते हो. सो दिस इज बायोरिएक्टर एंड दिस इज कॉल्ड द एल्गल बायोरिएक्टर. ये इसके ऊपर काफी काम हो रहा है क्योंकि कार्बन डाइऑक्साइड खा जाता है और फ्यूल बना के देता है प्रकृति से. बहुत बड़ी बात है ये दिस इज कॉल्ड कार्बन कैप्चर टेक्नोलॉजी. नेगेटिव कार्बन फुटप्रिंट्स आते हैं इसके, वर्ल्ड वाइज इस पे रिसर्च टेक्नोलॉजी को डेवलप करने को चल रहा है. हमारे यहाँ भी इस पे काम चल रहा था, मैंने इसको देखा है बायोरिएक्टर्स को वर्किंग करते हुए. इसमें एक रिएक्शन जो पीएचडी चल रही थी वो थी अलग अलग एल्गीज को कंपैरिजन करने की. लोगों ने अलग अलग वाटर रिसोर्सेज से, कोई गंगा नदी से एल्गी लाया तो कोई यमुना नदी से, अलग अलग रिसोर्सेज से एल्गी इकट्ठी करी सैंपल. कोई यहाँ के तालाब से एल्गी लेके आया अलग अलग, और उन एल्गीज को कन्वर्ट किया ट्राइग्लिसराइड्स में विद द हेल्प ऑफ द कार्बन डाइऑक्साइड एंड द सन रेज, और उसको फ्यूल वैल्यू उसकी कंपैरिजन करी किससे ज्यादा यील्ड मिलता है फ्यूल. लाइक दिस व्हिच वाज इन माय नॉलेज. वो तो ये एक इस तरह का काम भी हुआ है बहुत ज्यादा, और हो भी रहा है अभी भी कि उस एल्गी को ये ऑर्गेनिक रिसोर्स से बनाने का है. Very useful and very the oil can be converted into biodiesel or jet fuel. Algal bioreactors are also absorb carbon dioxide absorb करते हैं, इससे अच्छी कोई बात हो नहीं सकती. कार्बन फुटप्रिंट्स कम हो रहे हैं, कार्बन डाइऑक्साइड को वो कन्वर्ट कर रही है, इससे अच्छा कुछ हो नहीं सकता. एनवायरमेंटल बेनिफिशियल, तो ये एक हो गया. दूसरा बायोहाइड्रोजन. बायोहाइड्रोजन वो हाइड्रोजन है जो हमको केमिकल रिएक्शन से या वाटर को डिकम्पोज करके नहीं मिल रही है. As a biological chemical reaction, this is being formed. this is being formed, जो farm हो रही है. Biohydrogen is hydrogen gas produced using the microorganisms, algae or biomass instead of fossil fuel. It is clean and renewable energy source with a zero carbon emission. When used, biohydrogen can power fuel cells. हाइड्रोजन हमको मिल गई तो हाइड्रोजन को हम सीधे फ्यूल में यूज कर सकते हैं या उसको हम फ्यूल सेल में यूज कर सकते हैं. It can be used as a part in the as a component of the fuel cell, or it can be used as a hydrogen engine also in the vehicles. But large scale production is still limited due to cost and the technology challenges. Due to the cost and the technology viability and technological challenges are there, so still it is biohydrogen is not in very much use, or still the research works are going on. Then last is synthetic fuels. Synthetic fuels or the syn fuels are produced using advanced chemical processes, often by combining captured carbon dioxide with the hydrogen. These fuels can directly replace petrol, diesel, or jet fuel without engine modification. They are considered carbon neutral because of the CO2 used in production offset the CO2 emitted during the use. So these are the synthetic fuels or syn fuel. We call them syn fuel. Are produced using the advanced chemical process. अभी chemical process की details मैंने यहाँ पे नहीं cover up किए हैं क्योंकि this is just an introductory slide. I have not gone in detail of the synthetic fuels, often by combining captured carbon dioxide with the hydrogen. Combined with the captured carbon dioxide chemically, and gives the chemical fuel. These fuels can directly replace petrol and diesel or jet fuel without engine modification. They are the considered. मैंने इसको बहुत डिटेल में नहीं लिया है जितना मैं डिटेल में उनको लिया था मैंने. Because of CO2 used in production offset the CO2 emitted during the use. So these are the thing here. Now next point is the sustainability link. Sustainability link. We are in the last we are talking about the sustainable development link. तो उसके लिए 3 गोल हैं, इंटरनेशनली सस्टेनेबल डेवलपमेंट गोल्स ट्रेस आउट किए गए हैं इंटरनेशनली. तो 3 गोल हमारे बायोफ्यूल के साथ मैच करते हैं. SDG 7 सस्टेनेबल डेवलपमेंट गोल. SDG stands for development goal, which is affordable and clean energy. ये goal है, affordable and clean energy. SPG 7 focuses on access to affordable, reliable, and sustainable energy. It promotes increased use of renewable energy like solar, wind, and the biofuel, and encourages improvement in the energy efficiency. तो हमारा है कि ये biofuel का जो है ये वाले goal के साथ मैच करता है. Sustainable development goal number 7. Goal: a world where clean energy is available to everyone, reducing dependency on the fossil fuel. So this is the final goal. Then goal number 2, which is internationally developed, is a climatic action. SDG 13. SDG 13 calls for urgent action to combat climate changes and its impact. This includes reduction in the greenhouse gas emission, building climate resilient infrastructure, and supporting green technology like biofuels, which lower carbon footprints. Goal: limit global warming and protect communities from the climate risk. So these are the goals. कौन कर रहा है? ठीक है, climatic risk. अच्छा. Then sustainable development goal 12. So responsible consumption and the production. ये है aim to ensure sustainable use of resources, reduce waste, and promote recycling and circular economy practices. It encourages industries and the consumer to adopt efficient, eco-friendly production and the consumption behavior, including using fuels made from the waste biomass, a more resource-efficient and less wasteful source. This is the third one, which is the goal, which is over here. Now, I sum up this whole presentation and the thoughtful listening. Thank you very much. Any question, if you wish, I can try to answer.
Actually, sir, conventional engines, we can see in petrol engine, diesel engine, power is efficiency depends on the compression ratio. if we increase compression ratio, efficiency will get increased. But in this case, I saw that in new
Compression ratio,
increase
हाँ.
the compression ratio, so it will affect the efficiency.
Yes, obviously it will affect the efficiency. Utna, when we convert it, it is not as good as the convention engines. It is, we have to compromise on this thing here. So the performance deteriorates. Even BIOS gives a inferior performance. Even biodiesel performance deteriorates. So the performance deteriorates, but you save the environment. Your SDG goals are achieved, by sustainable development goals are achieved. The performance is obviously not that good, but yes. So they are there. The performance deteriorates. The brake power, decreases. Volumetric efficiency increases, but the emissions are less because better combustion. So that is there. So obviously ये तो स्टडी करते हैं, परफॉर्मेंस पैरामीटर निकाल के बताते हैं 10% ड्रॉप हो गया, 5% ड्रॉप, लेकिन कुछ चीजें अच्छी आती हैं, जैसे वॉल्यूमेट्रिक एफिशिएंसी इंप्रूव्स, क्योंकि वो कंबशन फिनोमेना आल्सो इंप्रूव्स, so that way it is beneficial also in some way or other way. And environmentally, because हमारा aim आजकल जिस तरह से मौसम बदल रहा है, right and left, the weather is changing, the changes we can experience in our domestic life, day-to-day life, we can experience the changes taking place day and night, and everywhere the changes are there. So we have to see that we have to bear the loss from the point of view of performance and the money, but we have to support the environmental cause. अब ये point आ गया है कि हमको करना ही पड़ेगा, भले कितना भी नुकसान हो, हमको monetary loss हो, but we have to go for the environment. We have to address the environmental concerns without caring for our monetary loss. So that is there.
So it's not loss; it's an investment for our future generation.
Obviously, because जिस तरीके से जिस रेट से एनवायरमेंट जा रहा है, चेंज हो रहा है, हमको खुद महसूस होता है. 10 साल पहले इतनी ठंड भोपाल में कहाँ पड़ती थी, आज क्या हो रहा है, अभी इतनी ज्यादा ठंड, कंसिस्टेंटली ठंड पड़ रही है. आप देख लो, आप ऐसा कोई दिन नहीं जाता है लगातार 8 डिग्री 6 डिग्री, ऐसा कभी हुआ है क्या? महीने भर से 6 to 8 डिग्री टेम्परेचर चल रहा है, तो वो तो हमको देखना ही पड़ेगा ना कि ये सब तो प्रॉब्लम है ही. तो हमको थोड़ा सा पैसे और मॉनेटरी लॉस पे और परफॉर्मेंस पे हमको थोड़ा सा नेगोशिएट करके हमको थोड़ा सा ये करना पड़ेगा कि हम इसको एनवायरमेंटल कंसर्न्स को टैकल करें. तो ये देखना पड़ेगा.
One more point I noted: we need 100 kg of biogas
Yeah.
to run 100 kilometers.
Yes.
But during Delhi municipal election, there was a big agenda, Kude Ka Pahar. So we can utilize that best.
Yes.
It's a political
Yes.
agenda. Why not?
बिल्कुल, I agree that if it is a bio waste, then it can be used for making the biogas. But it is an inorganic waste, then inorganic waste cannot be used. Inorganic waste can be used by burning it in a vitiated atmosphere, giving the water gas or producer gas, and that has got the fuel value. So in organic waste you can go for anaerobic digestion and go for the biogas, but inorganic waste जैसे कि बहुत सा इनऑर्गेनिक वेस्ट होता है जिसमें कार्बन नहीं होता है, तो वो वाला हम जिसको उसको हम कम ऑक्सीजन में घुटन भरे एटमॉस्फेयर, विशेषिएटेड एटमॉस्फेयर, इट इज बर्न्ड इनटू विशेषिएटेड एटमॉस्फेयर, तो उसमें कार्बन मोनोऑक्साइड रह जाती है, तो मोनोऑक्साइड इज अ फ्यूल, तो वो वाटर गैस और प्रोड्यूसर गैस के फॉर्म में हमारे को वो मिल जाती है, तो उससे हम फ्यूल के रूप में इंजन भी चला सकते हैं, उससे उसको यूज कर सकते हैं, तो वो तो है. ठीक. Any more any more question?
Thank you so much.
Thank you, sir. Thank you. उनको बोलना था ना कि लेक्चर में हूँ मैं, उनको बोलना था ना कि लेक्चर में हूँ.